Hello everybody, welcome to Chapter 6.4 Part 2, Rational Exponents. More examples with variables. In example number 12, we're asked to simplify x to the 1/3 times x to the 5/6 as much as possible. So here we're going to do a multiplication problem. So let us go over to the whiteboard and work this one out.
Here we have multiplication. Now remember our multiplication rules. So we have x to the 1/3 times x to the 5/6. And we know that if we have the same base, we have to add these two up. So it's x to the 1/3 plus 5/6. Now, as we see, what we have to do here is add the exponents, which means essentially we're going to be adding fractions. So on the side, I'll do this. So I have 1/3 plus 5/6. So I want to find the lowest common denominator, which is 6 in this case. So that means that here we're going to have 2/6 plus 5/6. Remember, when we're adding and subtracting fractions, the bottom must be the same. And in this case, we're simplifying, we're not solving. So we must do this, we can't just clear it. So now I'm going to change this to x2, so that means this is equal to 2 plus 5 is 7, and then 6. So that means my final answer here is 7x to the 7/6.
Reviewing what we just did in example number 12, we added up the exponents, but these exponents are fractional exponents, so we had to do fractional addition. And we found that we had to find the lowest common denominator, which was 6. So 1/3 becomes 2/6 plus 5/6, and we added up those two fractions to get 7/6. In example number 13, we have x to the 2/3 raised to the power of 3/4, and we want to simplify this as much as possible. So let us go over to the whiteboard and work this one out.
In number 13, we use the product rule, which is actually a little bit simpler when it comes to the arithmetic. X to the 2/3 to the the power rule to the 3/4. Sorry, the power rule. So here we have a power to a power. And so in that case, we multiply these two. So if we have 2 times 3 is 6, and 3 times 4, so we end up with x to the 6/12, and then we have, that means it's equal to x to the 1/2, which is the same thing as the square root of x. So we have to reduce. So with multiplication, we can just do it straight through, and this is our final answer.
Reviewing what we just did in example number 13, we saw that this is the power rule of exponents. And that means we multiply them. So when we multiplied them, we got 6/12, and then we reduced to get x to the 1/2. In example number 14, we're asked to simplify z to the 1/3 power over z to the 1/4 power as much as possible. So let us go over to the whiteboard and see how to do this one.
In example number 14, we have z to the 1/3 over z to the 1/4. And as you recall, this is going to be subtraction. So that's going to be equal to z to the 1/3 minus 1/4. So 1/3 minus 1/4, since they both have the same base. And on the side, we'll do the fraction subtraction. and the lowest common denominator is equal to 12. So that means this is 4 over 12 minus 3 over 12. So that's going to be equal to 1 over 12. So that means that our final answer is going to be 1 over z to the 1 over 12. And that's our final answer for number 14.
Reviewing what we just did in example number 14, we had to subtract the exponents because that was our quotient rule, but again, we have to do it with fractions, so we have to subtract the fractions, which means we had to find the lowest common denominator, which was 12, and by subtracting, we got 1 over 12 in the exponent. So our final answer was z to the 1/12th power. In example number 15, we're asked to simplify a to the negative 1/3 power over b to the 1/2 power and the entire thing to the 6th power. So let us go over to the whiteboard and work this one out.
In number 15, we do a lot of different things. So here we have a to the negative 1/3 over b to the 1/2 to the 6th power. So we're going to simplify as much as possible. So what I'm going to do is use the power rule to bring the 6 in. So I have negative 6 over 3 on the top, and here I have b 6 over 2 on the bottom. Now I see that it makes things nice and easy because this fraction 3 goes into 6, so that's equal to negative 2. And then the bottom I have b is equal to 2 goes into 6, so that's going to be 3. And as we learned earlier, we don't want any negative exponents, so we're going to bring this downstairs and turn it into a positive exponent. And remember to put your 1 on the top, a squared b cubed, and that's your final answer. And remember to put your 1 on the top. 1/4 of a pizza pie is not the same as 4 pizza pies.
In reviewing what we just did in example number 15, we multiplied in the exponent 6 to the exponent negative 1/3, and that means we got a to the negative 6 over 3, which becomes a to the negative 2. And similarly for the bottom, we multiplied the exponent 6 times 1, the b exponent 1/2, and we got b to the 6 over 2, and that gave us b to the 3rd power. And then, because we have a negative exponent up here in the a negative 2, we had to move that downstairs and make it positive. And that gave us 1 over a squared b cubed. In example number 16, we're asked to simplify x to the negative 1/3, y to the 1/2, over x to the 10th, y to the 3/2, all to the 4th power. So let us go over to the whiteboard and work this one out.
So for number 16, we have x to the negative 3, y to the 1/2, over x to the 10, y to the 3/2, and all of this, the whole thing, is to the 4th power. So what I can do is just multiply the 4 in. So I have x to negative 3 times 4. I have y to the 1/2 times 4 over 1. If you want to write it that way, just for placeholders. Then you have x to the 10 times 4. And then you have y to the 3/2 times 4 over 1. Then you go about multiplying it, so then you have x to the negative 12. And then here you have y squared when you work it out. 10 times 4 is 40. And then here, when you work it out, you get y to the 6th. And then you work out, so you have negative 12 minus 40, so you get x to the negative 52. 2 minus 6 will give you x, y to the negative 4. But remember, negative numbers, we must remember our 1 on the top. We want to make it positive. X to the 52, y to the 4th.
Reviewing what we just did in example number 16 on the whiteboard, we multiplied in the 4 based on our exponent rules, and we got x to the negative 12 y squared over x to the 40 y to the 6th. And then we worked this out, and we got 1 over x to the 52 over y to the 4th power. In example number 17, we're asked to simplify the expression a squared b cubed to the 1/6 power. So let us go over to the whiteboard and work this one out.
17, I have a squared b cubed all to the 1/6. So that means I multiply that in. A to the 2 over 6, b to the 3 over 6. So that's equal to a to the 1/3, b to the 1/2.
Reviewing example number 17, we split up the a's and the b's to get a squared to the 1/6 power, b cubed to the 1/6 power, and then multiplied in the powers to get a to the 2/6, b to the 3/6, and that gave us a to the 1/3, b to the 1/2. In example number 18, we're asked to simplify the expression p to the 1/4 power over p to the 3/4 power, all to the 8th power. So let us go over to the whiteboard and do this one.
Number 18, we have p to the 1/4, p to the 3/4 to the 8th. Of course, when you see into these things, it's much easier. I did it a little different on the PowerPoint, but that's okay. As I said, there's many roads that you can take so long as you get to the right house or the right place. So we have p to the 8 over 4 over p to the 3 over 4 times 8 over 1. So that'll give us p to the 2 over p to the 6th after we work all this out. And that will give us, and we see that it ends up being p to the negative 4, 2 minus 6. And remember, always put your 1 on the top when you have a negative situation. Remember, 1/4 of a pizza pie is not the same as 4 pizza pies.
Reviewing what we just did on the whiteboard, we did the subtraction, and we subtracted the exponents, and we got p to the 1/4 minus 3/4. And since these both had 4 in the denominator, it was relatively easy to do the subtraction. So we ended up inside this bracket, p to the negative 2 over 4 to the 8th power. That is equal to p to the negative 1/2 to the 8th power. We multiplied in the a, and we got p to the negative 1/4, but then we have a negative exponent, so we had to make it positive, and using our quotient rule, we have 1 over p to the 4th. In example number 19, we're asked to simplify the expression 4x to the 3/4 y to the 1/6 all to the 3/2 power. So let us go over to the whiteboard and work this one out.
In example number 19, we have 4x to the 4/3 y to the 1/6 all to the 3/2 power. So now I'm going to bring in the 3/2 through the whole thing. So I end up with 4 to the 3/2 x to the 4/3 times 3/2 and y to the 1/6 times 3/2. Now this one, to evaluate this, it's the same thing. Remember, this will tell us the square root, and we know the square root of 4 is 2. And we bring that to the third power. So we know 2 to the third power is 8, so this will be 8 here. Here, I'll do on the side the arithmetic for the power. So we have 4/3 times 3/2. So 2 goes into 4, and we're left with 2. So that gives us x squared. And then for this one, we have 1/6 times 3/2. And so here, 2, so that's equal to 1/2 times 2 is equal to 1/4. So that gives us y to the 1/4. And that's our answer.
Reviewing example number 19. As mentioned, since rational exponents are exponents, we can use the properties of exponents to simplify the expression. And that is what we do. We multiply in 3/2 to get 4 3/2, and then we have x to the 4/3 to the power of 3/2, y to the 1/6 to the power of 3/2. And then we work that one out too using the rational exponent theorem, and we multiply exponents. And if you like, we can turn the 1/2 power into a square root and bring that to the third power. When we multiply 4 times 3 we get 12, and 3 times 2 we get 6, and 1 times 3 we get 3, and 6 times 2 we get 12, and then we simplify this to get 2 to the third x squared y to the 1/4, and that gives us 8x squared y to the 1/4. In example number 20, we're asked to simplify the expression 10b squared c squared over c cubed root of 8b to the 4th. So let us go over to the whiteboard and work this one out.
So let's see how we would do something that's kind of mixed up. We have 10b squared c squared over c cubed root of 8b to the 4th. So if we separate out everything, so then we have is equal to 10b squared c squared c cubed root of 8 cubed root of b to the 4th. And we already know that cubed root of 8 is 2. So that means we have, so we'll put 10, this is 2. So we have 10 over 2 Then let's look at the b's. Well, we have, for the b's, we have b squared. And we're going to rewrite this as a rational exponent so we can evaluate it more easily because we have this power and that. So we have b to the 4 over 3. And then we look at the c's, and we have c squared over c. So I just did this for bookkeeping reasons to kind of organize everything so I don't get confused. And I see that, well, this is going to be 5. 10 goes into 2 5 times. And then I have b squared. Well, I'll do on the side the arithmetic. So I have 2 over 1 minus 4 over 3. So I work it out. Lowest common denominator is 3. So I have 6 over 3 minus 4 over 3. And that gives me 2 over 3 for that one. So here I have 10 over 2, as we mentioned, is 5. I'll just move that over here. 5. And now I have b is 2 over 3. And then I have 2 minus 1 is just c. So this becomes my final answer. So really, when we have root signs, by putting it in terms of its rational, putting it in terms of taking it out of the radical and putting it in terms of rational, can make our calculation much easier in order to simplify our final example.
Reviewing what we just did in example number 20, we separate the factors in the denominator. Then we take the cubed root of 8, which is 2. We rewrite the radical using a fractional exponent. We rewrite the fraction as a series of factors in order to cancel factors, and here we do it. Simplify the constant and c factors, and simplify the b factors till we finally get 5c b to the 2/3 power, and that's our final answer. Thank you very much. I hope you enjoyed this video. Be well, take care, and goodbye for now.